Давайте продолжим нашу работу.
Okay, colleagues, let's continue. We're about to start a roundtable discussion on the development of sustainable navigation in the Arctic. We'll split it down the middle as well, because there are a lot of panelists, and the format is going to be the same as during the plenary. The participants of this session are Mr. Alexeyev, Chief Research Fellow of the Ocean and Atmosphere Interaction Unit at the ARI, Mr. Mironov, Chief Research Fellow, Head of the Ice Forecasting at ARI, Mr. Maximov, Deputy Head of Isoplanet, Mr. Soldatenko, Lead Research Fellow at RE. To start off the first part of our roundtable, let me say a couple of words at the beginning. The entire agenda for developing the Northern Sea route is currently impossible without reliance on sea navigation. In the first part of the conference, we addressed and discussed the risks that come attached to Arctic projects. And now let's shift gears and speak about research of these issues. Because the sea conditions are constantly changing, and over the past 40 years, the amount of ice has decreased dramatically. The lowest levels were registered in 2007, 2012, and other years around them. But the amounts of ice became challenging in the recent 2 or 3 years. So it's not as straightforward as might seem. And we'll have a deep dive during this session into that. As for ice navigation, ice forecasting, this is the specialty of our Arctic and Antarctic Research Institute here. So we are well aware of the principles for ice sea navigation, since we were at the very beginning of them. Hopefully, the observational network for monitoring will be developing, including unmanned buoys. There are such buoys near the North Pole Station, and they are indeed very informative as regards the environment and climate. We'd like to raise awareness of our capabilities to the public at large and to the business community, because we have some developments in logistics, in safe navigation in icy conditions, and in operational forecasting and modeling. Mr. Alexeyev, let's start with you. Evidently, the Arctic region is the most sensitive to climate change. We observe accelerated heating in certain regions, sometimes 4 times faster than the rest of the planet. So can you tell us a bit more about all this, so that we have some idea of the future? Please stick to the timing, 8 to 10 minutes. Hello, colleagues, dear guests. I'll speak about the manifestation of global climate change in the Arctic and on some certain specific features that it has in the Arctic. Global warming overall is the increase of air temperature in the North Pole or in the South Pole and then globally. Globally, warming started somewhere around 1970s or 80s. It's reached a plateau now, but it is different in the Arctic. Warming came into here a bit later. There are charts on how the temperatures changed in the northern ocean and along the Arctic northern sea route. It started somewhere in the 90s. The rate of change is shown on the bar chart. Usually it's peaks in the summer and winter, or fall and winter, and it's at its lowest in the summer. The velocity of warming is much faster in the Arctic. One of the key factors is that air flows between the polar region and the adjacent latitudes has intensified, which accounts for almost 70% of temperature increases in the region. So basically this is the main reason for more intense warming. I'll come back to the second reason a bit later. And also noteworthy is that the ice covering of the ocean is reducing, including the northern sea route. Ice covering and its trends are shown on the charts in the ocean and on the northern sea route. The most prominent trends are shown in the Arctic Ocean during the warmer part of the year through to October. The shorter duration of summer periods has had to do with the changes in temperature. And then there is a relation between a reduction of ice and its impact on the warming in the Arctic and in the entire hemisphere and globally. This has to do with albedo. We have looked at the reflective capacity, and in summer it prevents warming, whereas during fall and winter the heat accumulated in the ocean is released into the atmosphere as the ice is melting, which accelerates the trend. So here are the main factors that drive warming and reduction of sea ice in the Arctic. First, this has to do with the inflow of heat and water vapor from lower latitudes during winter. This increases the amount of incident radiation, shortwave radiation, that determines the parameters of ice. It melts at a different time, it has different thickness, as you can see in the charts. Then, we have also established that warming and ice reduction in the Arctic are remotely but connected to lower latitudes. The northern part of the Atlantic Ocean, for example, has influence on the Arctic region. The lag there is 3 to 4 years, so there is some predictive capacity in this observation as well. Projecting forward, we can rely on models, global models, that are shown in the top row of the charts. the projections have been lagging behind the actually observed reduction of ice. This is one of the drawbacks of global models because they are relatively poor at forecasting the processes in the Arctic. This has to do with reduction of ice, inflow of warm water, and its presence there. Since these models are not as effective, we have to rely on empirical dependencies and long-term forecasts. The slide shows some of the forecasts that we produced for the nuclear fleet through to 2030 or 2050. We do not expect any catastrophic reduction of ice in the region. The conclusion is that global models are not yet reliable enough to inform long-term forecasts in the Arctic, including its ice situation and other parameters. That concludes my report by way of an introduction into how the climate is changing in the Arctic. Thank you very much, Mr. Alexeyev. Now we can go local from this global level. Let's look at operational forecasts. Short-term ice forecasts for the Northern Sea round have an accuracy of 90 to 95% currently. Long-term are a bit worse, but still 80-85%. Mr. Brestkin, could you tell us a bit more about this local component of research to narrow it down from the global picture that we've just seen? We'd like to hear about long-term forecasts and operational forecasts and their role in improving the efficiency of navigation there. Let's put up the next deck. Dear guests, Mr. Moderator, today I'd like to tell you about the techniques and methods in ice forecasting that support all year-round navigation in the Northern Sea route. These are techniques that are already in place, as well as certain methods that are currently being developed. It is a relevant objective, mostly due to the overarching goal cascaded to us to ensure all year-round navigation on the entire Northern Sea route. Currently, navigation during winter is only possible in the Kara Sea. By the year 2025, we are tasked with supporting winter navigation in the seas of Laptev, Northern Siberian, and Chukotka Sea. It's a tall task for us all, and it's a challenge for hydrometeorological support systems because it requires a new level of quality and timeliness. Another important objective here is making navigation faster. This is dictated by the interests of efficiency and safety. This can be achieved through optimal route design, also informed by the ice situation forecast. There are different types of ice forecasts at this moment. Short-term forecast of ice distribution and migration, up to 5 days ahead based on dynamic thermodynamic models and discrete elements. Then there are long-term forecasts of ice intensity and ice cover distribution, 15 days out to 3 to 6 months out based on physical statistical models. Last but not least, there are recommendations on optimal routes out to 5 days and scenario of transit navigation out to 30 days. key parameters here are thickness of ice, disruption of ice and all of its features, strain and tension in ice, and the location of icebergs and grounded hummocks, stamujas. Based on these parameters, we intend to develop our forecasts further. Here is an example of one such forecast. It's based on a numerical model that forecasts distribution of ice and its strain and tension parameters at a resolution of 78 hours. A new technique allows to forecast shorter time frames with disruptions in the ice cover. The direction is shown by the lines in the quadrants. Colored quadrants show extension and compression within the ice. Long-term forecasts project out a whole set of parameters with the longest forecast period up to 6 months. This includes the timeline for ice formation, which is very important, ice thickness, the locations where ice builds up, the timeline for ice removal, and timelines for ice-related events in the fall. Ice is very important for navigation, including optimal design of navigation routes. Our approaches here are based on modern vessel parameters not supported by icebreakers. We also rely on remote sensing technologies that allow us to track data across time. And we are also developing an auto-routing method. It's expert-based and yields recommendations on optimal routes 3 to 5 days out within a given sea. Here are the estimates of the accuracy of our forecasts over the past 5 years. Across different parameters, you'd get different accuracy values, but on average, short-term forecasts are 93% accurate, which is sufficiently good performance. As for long-term forecasts, the accuracy is lower, which is obviously related to the forecasting period, and the average is from 83 to 85%, which is above the climate forecast accuracy by 15 to 20%. Then there are advanced forecasting techniques as well that should improve the efficiency and accuracy of planning in navigation in the area, including transit. This should improve safety of navigation based on recommended routes, as well as ensuring efficiency and safety of moving mobile geosurvey and production rigs, which has been on the rise as an activity in the recent years. Thank you for your attention.
Thank you very much as well. We are moving from big global climate models to more specific questions. Maybe you could do the follow-up on this topic, and you could present the entire complex of hydrometeorological assistance that is created by the Institute for the Navigation. It's not only about ice forecast, it's about different layers of information. Yes, I'm going to say only a couple of words. I wanted to talk about another thing. For ice forecasts and recommendations to be developed, we need to ensure space images of the ice coverage, including radio ones, based on these pictures and other information sources, data from stations, data from vessels. We need to create diagnostic ice maps, and we have different types of them: more detailed, less detailed, surveillance. We also need meteorological forecasts. Altogether, it allows to develop forecasts that were presented by Mr. Mironov. In my brief speech, I would like to draw your attention upon the importance of the development of the entire complex, starting from satellite images, their treatment, their attachment, and going down to the choice of correct routes. The key word in my title is all-year navigation, all-year-round navigation. This task has been defined quite strictly. Starting from the beginning of 2024, the Northern Sea route should be navigable during all 12 months, including its eastern parts. The true winter, ice-wise, starts in February. In January it's cold as well, but the ice remains thin. February, March, April. In May, conditions start to improve. The sun starts to work. Starting from 1978, we had experimental trips in May-June. Still a severe winter in the Arctic, but the ice starts to decompose. So the possibility of all-year-round navigation was confirmed back then, eastbound. In the western part of the Arctic, this issue has been solved back in 1978, 1979. I think that you read through my slide already. It was not complicated compared to the goal we have now in hand, because the surface was not enormous, only the southwestern part of the Kara Sea. From Dixon going east, no one works there. And from Yenisei Bay and Opmouth to Karagate, during a short period of time, this part is covered by the anticipation of detailed forecasts, and the recommendation can be made to the entire complex. But back then, it seemed simple, but a systematic approach was used full-fledgedly. It was a tight cooperation between three important ministries: the Ministry of Civil Aviation, the Ministry of Meteorology, and the Ministry of the Arctic fleet. And the supply system worked as a system per se. They had several subsystems like icebreakers support. Nuclear icebreakers used to be constructed specifically for all year round navigation. Their shape, their size, or in line with the shape and the size of vessels of the ice class. They were working as a unified system amid difficult ice conditions. The vessel got closer to the hullback of the icebreaker, and they went together. The Sever system was created back, and the satellite group was organized. And it included radio navigation satellites. So navigation subsystem and port control subsystem worked as well as a system, and it had one management office. All systems were subordinated to the direction of sea navigation. So the coordination question was solved from day one. From 2017, extra early and extra late voyages started. January, February, March, April, where Yamal Max tankers appeared. Christophe de Margerie was the first vessel of this type. It worked with 50 years of Victory icebreaker. You see the difference in dimensions. You have a couple of minutes left only. You have only a couple of minutes left. Yeah, I'm wrapping up. You see, the vessel itself is much larger than the icebreaker. So the systematic approach was not there anymore. What challenges are expected when organizing winter navigation through all months, including March and April, eastbound? The length of the voyage is 5 to 6 times longer versus what we have in the western part now. The monitoring of ice coverage will be much more complicated because the surface is much higher compared to the Kara Sea part. In the western seas, weather conditions are much more harsh versus what we have in the eastern part. And it's even more important is the time of the voyage, 1.5 to 2 weeks. So we don't have detailed ice forecasts because it takes so long. You cannot pick the route and understand the ETA quite accurately. During the navigation itself, you will have to correct your route. This is what makes this task even more complicated. We brought together the experience of extra early and extra late voyages from 2017 till 2021. I will not comment this slide. I'm gonna stick to this one. The analysis of voyages, of passages, we were looking at every part of the route and having ice coverage in mind. Super Yamal Max tankers can, independently, with no ice breakers support, sail east, should they have enough meteorological data. Icebreaker assistance may not give enough gain time-wise. And the third conclusion, that nuclear icebreakers are more efficient when they are on duty at complicated issues. So should a vessel be trapped in the ice, an icebreaker should come and free it out. Wrapping up, I want to say that back in 1980s, when the all-year navigation in the western part of the Arctic was defined, a systematic approach was used. In this much more complicated scenario, and I explained why it is more complicated, this systematic approach suffers. First, costs are unbalanced. Way too much too less attention and too only few amount of money are invested into the meteorological surveillance. This is what has been told in the first part. We need more icebreakers and more icebreakers, and we won't have enough of them, nevertheless. This shortage in icebreakers could be compensated partially with the development of the hydraulic and meteorological support. The ice in the Arctic is distributed unevenly. So if we use this data, many vessels could sail on their own. And the positioning of icebreakers and the icebreaker assistance could be more efficient. We need to develop ports, icebreakers, but on top of that, we need to have good system, hydro and meteorological support. With satellite group, I Only Cry, we have a fantastic ocean system of satellites. Radio navigation satellites. We don't have them anymore. Americans, Canadians, Europeans, they refuse to provide us with the images. We use Chinese information, but it's complicated to work with Chinese. And we lack in severe system modernization. Starting from 2011, we have this task to modernize the server system, because the current system, all software was developed back in the beginning of 2000s. It was obsolete even in 2010. And then the modernization was postponed in 2021. In 2022, it was put on hold once again. So these issues, when managed properly, could allow the navigation in the eastern part of the Arctic. And highly likely it's gonna be economically efficient, but the systematic approach is a must. This concludes my part. Thank you, Sergei. I want to add on top of that, if I could, the severe modernization was put on a halt in 2022. Due to some objective reasons, we cannot buy hardware that we wanted. Now in 2023, the work has continued, and I think that success will come. And together with our colleagues from Rosatom, we would be able to understand what information should be prepared in what format to ensure the safe navigation. You told about our satellite group. Maybe you can elaborate on the current satellite constellation and about what is being planned. For us, it's an important question. For navigators, it's also an important question. I mean, access to satellite information. Hello, dear colleagues. First and foremost, I would like to thank the organizers of the conference for inviting me, for giving me this opportunity to take part with my presentation in its work. As it was mentioned before, sustainable navigation is inherently related to the improvement of the hydrometeorological information. I will talk about existing and potential Russian satellite systems used to assess meteorological conditions in the Arctic. Onshore, we have three centers, NITS Planeta. It allows to receive timely satellite data not only over Russia but over adjacent countries as well. Within the Federal Space Program, up until 2025, we plan to project 14 space vessels. 6 of them will give information about hydro and meteorological information in the Arctic. Meteor Arctica series, as well as Kantorovka and Obzor Air space bodies. Yes, the situation is quite complicated. It's far from being satisfactory. As from now, from the Meteor satellite constellation it has degraded. We have only 2 satellites over the Arctic. The second one working with the limitation, and we have only sub-elliptic apparatus Arctica M. We have an ambitious development plan. Among Russian constellations, we have only Electra with 3 pieces that works fine. In February, we had this opportunity to keep track of changes of synoptic processes over the European part and go into the Russian Far East. We can take a look partially at the eastern cargo corridor. Because of their technical limitations, canopies are not being used to work with the hydrometeorological conditions. Some pieces of equipment just don't work. You can see that up until 2030 our plans are quite ambitious, and all that is mentioned above allows to conclude that only one spacecraft of Arctica system and one spacecraft of Meteor system allow us to understand what's happening in the Arctic. In 1 month, we plan to project Meteor 2.3, and it has on board an onboard radio detection and region equipment. And in September, another satellite from the Arctica series will be launched, and the amount of data received from the Arctic will increase considerably. I'll brief you on information products that are available based on satellite data. The main volume relates to the is received from the Arctic satellite. We analyze weather conditions, sea and ocean conditions, monitoring of hazardous events, and control of and environmental control. As an example, you can see what we have. These are the data that we receive from the Arctic satellite. But we receive it only during 2 6-hour periods. So during 2 other 6-hour periods, we don't have any information about the region. As Sergei said, we need not only forecast ice conditions, but also forecast meteorological conditions. And raw data are very important to this work. So using one Arctica satellite, we can receive information about the distribution of wind at different altitudes altitudes, and it's used in mathematical forecast models. And after the second satellite is projected, we will receive information 24/7, which will increase the weather forecast accuracy. Based on Arctica data, we can define cloud conditions and water saturation in the clouds to forecast precipitations. Joint analysis from the Arctic satellite and other data sources allow to track maximum wind speed to detect precipitation area and its intensity, to define local atmosphere convection regions. One of the priority satellite synoptic meteorology is to watch over large-scale polar cyclones. Partially the data is being received from the Arctic satellite. We hope that the second satellite would give an opportunity to see the creation and the evolution of that. It is widely used, the information, to cover aviation flights, hydrometeorological service of the military uses that. We have 1 minute. Yeah, I'm just gonna conclude it.
Vertical imaging of clouds and icing regions, all aggregated within one system. Here's an example of Russian-made instruments used to monitor the polar station that we are doing on the instruction of Russian Hydrometeorological Service. We mentioned ice maps already. I'd like to underscore that high-resolution migration can be tracked as well. And then there are satellite communication applications as well. Then we can look at sea ice, its boundaries and propagation. That's pretty clear. But then we are also monitoring the surface area of permafrost in the Russian Arctic. And up to 2005, we see that it was the largest. Then it went up and down, but it's been recovering recently. To the west, however, we can see that the surface area of old ice is receding, but one last year bucks the trend, and the area was 480,000 square kilometers. To conclude, I can only agree with the previous speakers in saying that our satellite constellation needs to be developed further, including to improve the quality of ice forecasts and hydrometeorological support. We need not just radar satellites, but specialized hydrometeorological craft as well. Thank you. We are running a bit late, but I think it's going to be okay. Let's take a step back, go to the beginning of our session, and speak about adaptation to climate change, where we are headed, and how we can adapt. Mr. Soldatenko. Hello, colleagues. In my brief presentation, I will focus on adaptation. First and foremost, there is an academic and political consensus in terms of the evaluation of climate change and its causes, the validity of these assessments, and the predominance of the anthropocentric cause is up in the 5 nines, which is the golden standard in theoretical physics. Climate change in the Arctic has its distinctive features that are listed in the slide. First, there is the Arctic amplification, where the rate of warming is much higher than in the rest of the globe. There are no reasons to believe that climate change is going to stop. So what we have to do is to adapt. As a concept, this was introduced in 2001 by IPCC in one of its reports. You can see the definition in the slide. Adaptation is adaptation, right? There are a lot of documents and publications that address climate change and adaptation. All of these efforts are synthesized by IPCC papers, Russian Hydrometeorological Service papers, and other national publications. This year, we adopted the second stage of the plan on adaptation adopted by the Russian government. Previously, of course, there was the first stage. There are two key sides to adaptation. First, there are climate services, where we need to develop emissions scenarios and come up with climate projections to forecast what the climate is going to be in the future. Then we need to assess the effects in different planetary systems caused by the climate change. Climate modeling data are also used in the evaluation of climate risks. It centers around the concept of vulnerability, which is in turn based on sensitivity of different systems to changes in climate parameters. Then there are adaptive capabilities attached to each system. In this regard, I think that everybody is speaking about adaptation. If you look at the publications, mostly the authors offer their judgments. It's not quantitative. Permafrost is going away, the temperature is going up, and it, of course, does affect the infrastructure, without any implications listed or evaluated or conclusions drawn. I've looked at many documents, including the national plan that I mentioned. It includes 17 actions, out of which most come down to producing a paper report. Just one action point stipulates that climate impact assessment methods need to be designed, but it doesn't expand on how to do that. I looked at the documents produced by ministries and agencies that were produced as part of the first stage plan of the adaptation. The documents provided for coverage or discussion of climate change effects in the context of any given ministry or agency, including such aspects as adaptation and vulnerability. They're all just pretty words, and it's not a Russian ailment. All around the globe, these papers are full of expert judgments that are subjective. But we need objective evaluations, and there is just one way to do that. These efforts need to be grounded in mathematics. Adaptation means that you address the consequences without looking at the causes. As we are adapting, the climate will be continuing to change. Yet there is one radical adaptation measure that can prevent further climate change effects, which is geoengineering. There are some experiments in this area already. But there are a lot of opponents to this. Lawyers, activists, a lot of people who are against it. But we might arrive at a point where we don't have anything else to do other than taking such radical steps. It's not as pressing today, but we still need a scientific approach to adaptation. Adaptation is about the interaction between humans and nature. We can look at it through the lens of cybernetics, because it's a closed control system. The agent is the government, national level and the local level, and the object is the environment. Any closed system would have active feedback. We have monitoring tools where these inputs must be used to take rational decisions to offset the effects of climate change. But in order to properly discuss adaptation, we need to know the effects on climate change on certain systems, because sometimes you don't have to do anything. Some systems could even benefit from the changes in the climate. So, in order to make a quantitative assessment to evaluate the effects of climate change on any given system, we need mathematical models to simulate these systems. Then there are theories of dynamism and sensitivity that can be used to get quantitative assessments. Before you do that, of course, you need to parameterize the effectiveness and efficiency of the systems, but nothing like that has been done or being done or even discussed. Here is an adaptation cycle proposed by the UN. Again, a lot of words, a lot of hot air. A lot of things are needed, but nothing is justified. Once again, our national plan, the second stage, includes 17 actions, mostly administrative, legal, awareness raising. But who's going to be the teacher? It's going to be introduced in the universities as well, but what the content is going to be is still undecided. So my point is that to discuss this with any gravity and to try and achieve any tangible result in adaptation, we, or I don't know, the government needs to define such objectives that engage research institutions to design mathematical models for all of those systems. I think there was just one publication dating back to 2008 by Professor Lazor of Boulder. That's the only time the impact of climate variables on regional economies is mentioned and discussed in a proper scientific fashion. To conclude, well, that's pretty much it. You need the models. Thank you. That was more of a pessimistic take on the state of affairs. But you're good at highlighting the pain points, so it's a lot of food for thought, indeed. We are going to rotate the panel again to proceed to the second part of the roundtable. We have Yuri Gudoshnikov, head of Arctic Shelf Laboratory. Please come up on stage. Mikhail Grigoriev, head of GECON, our old friend, great partner. Nikolai Doronin, chair of the management board of the Project Office for Development of the Arctic. Yuri Ugrimov, Deputy Director of Expeditions at ARI. And Mr. Sudov. There is a bit of a reshuffling. Unfortunately, Yuri Petrovich is not available, and his colleague will be stepping in for him. So while everybody is getting seated, we have a moment to set your mind straight for this part of the discussion. Previously, we addressed the climate, the contexts. We've zoomed in from the global level to practical field applications. And now, I'd like to speak more about the current situation in the Northern Sea route and in the Arctic region overall. Let's start with Arctic Shelf, a magnificent laboratory that has been exploring the region for 2 decades now, providing support to all types of activities in research and production, and they hold unique experience of working, well, not only on the ground, but on the water and on the ice. Let's try to stick to the timing as well. Hello, colleagues. I'm here to present a collective report on the activities of the Zubakin Lab for Exploration of the Arctic Shelf, highlighting some of our achievements and some of our pain points. This is a map of our geography of our operations. We have activities in all seas, from the Barents Sea to the Chukotka Sea. There are a lot of projects. Primarily, these are field studies, expeditions, and also analytical work, reviews, synthesis, modeling. For example, modeling of cargo unloading onto static ice. Most of our publications and activities have been focused on the northern part of the Russian Arctic, the Barents Sea and its premises. Among the largest projects there, where we provided support or participated or led the efforts, we have unprecedented research for the Stockman deposit. It was in operation from 2009 to from 2001 to 2009. It's a long time. There were 8 fully fledged expeditions, other jobs, surveying, and other studies. Unfortunately, that deposit has been put on hold, but the scope and scale of research is unprecedented for just one project. Then we have Prirazlomne ice platform and Sabetter seaport in the up mouth. These projects have been completed already. They are well publicized, and you can even see them on TV, in the news, and in the ads. Here is a chart that summarizes different trends that we've observed, how our projects developed over time and across different seas. The Baltic Sea is pretty evident. That's where we are located. So we are well positioned to participate. Then, since 2006, there was this movement from west to east. This used to be the Barents Sea and Pechotskaya Sea from 2004. Then 2005 we went to the Kara Sea, the Outmouth, Yenisei Bay. Starting from 2014, we expanded our operations to the Laptev Sea, Chukotka Sea, now spanning the entire Arctic shelf. What else is there? We get a lot of new projects, and then we've seen that priorities have been shifting from open sea areas to coastal areas. There are ups and downs to that. There is an upside and a downside. For one thing, logistical support is easier. It's safer to work on shore as compared to the sea. Of course, on an expedition, safety is relative because it's a hazardous environment, but still. We have hydrometeorological stations located along the shore that can be great help. And natural processes are impacted much more by human activity closer to the shore, of course, and you need to factor that in. Another limitation is that we need to comply with local jurisdictions, regional jurisdictions, and license rights in the regions. That can be a constraint which sometimes prevents you from fully tapping the potential of your study. As for anthropogenic impacts, here are some examples. The northern part of the Outmouth, around Sabeta and the Salmonov deposits. And you can see clearly that in June, the ice detaches, and before 2010, navigation there was very sparse. And now it goes in straight lines along the channel, which is a clear effect of ship traffic there.
All in all, the situation that we have is here. We discover more and more deposits, new deposits, and the priority is shifted towards pre-shore deposits. There are a lot of them, and they are more easy to be developed. We have several issues with depth extraction of hydrocarbons. This is the current trend. Next trend to be mentioned is the following. Our clients' competences grew better in terms of weather conditions to work in. And we see new tasks emerging. When we participate in smaller projects, we have more and more engineering tasks. And the new tasks that I mentioned, like modeling of the functioning of isolated elements of the transport infrastructure. Last year, we worked on the modeling project to transport oil in the Kara Sea. We used modeling, and in this model we introduced all technological and transport operations. And first and foremost, it was done taking into account hydrometeorological factors. This is a picture just to show the number of parameters that were taken into account. So we brought together hydrometeorological parameters and technological processes. We were able to understand time spent of the vessel in the port, time of waiting in line, the time of being in the sea area, the number of embarkments, peculiarities of their functioning, frequency and time of the absence of oil in the pipeline leading towards the reservoir. We have a couple of minutes left only. Next trend. The project became shorter, cheaper. Yes, we've been in the Arctic for many years and we have the base, the foundation we should stand on and give the results cheaper and quicker. I would like to highlight the participation of our employees in the development of the legal framework. We participate in the standardization committee. We were involved in drafting new legislations. New equipment is used, new technologies are being used. And I will not voice out, just you can read through issues that we face. This concludes my presentation. Thank you very much for painting this big picture of ups and downs. So all in all, where do we move? You are the person who is better placed. Mr. Grigori, if you have the floor. I would like to give you some examples, some results related to the Northern Sea route. Amid the current geopolitical situation, the Northern Sea route gained its importance. Its function is the route that will segue Russian goods to the friendly, so far Asian market. So it's the famous turn towards the east. Traditionally, we have mineral raw materials. Also, the Northern Sea route is used to transport goods from Barents Sea, White Sea, and Baltic Sea as well. The international transit lost its relevance, first and foremost because of the position of the EU, and second, the freight rates collapsed per container over the last year. So let me skip this through. Last year, cargo traffic decreased by 1 million ton. 2 ton less in transit goods, and 1 million ton less of our own goods, raw materials, like LNG. High production of LNG was related to the fact that maintenance had been deferred. This year, Novatek said that it had found the company that would do the maintenance. So, without any new players coming on the cargo market this year, this downwards trend will continue. Every increase in cargo traffic is related to green and red columns. Red stands for LNG and oil, and dark green stands for oil, which means oil from Novopartovsky and gas from Yamal SPG. Arctic oil, one of two components of the Arctic cargo traffic. We have very good shuttle schemes of oil transportation, two oil handling hubs in the Kola Bay. One from Varanday and another. Not that physical mix, they bring together at one tanker Prirazlomne and Novy Port from the region of the Northern Sea route. What I would like to draw your attention to, upper right-hand side corner, trends of oil transportation from Murmansk, where different cargo streams are accumulated. Less than 200 million tons. Everything became yellow. Everything is being transported to Asia. The height of the columns, you can see that starting from December, the minimum height of the lowest column increased. We changed from Aframax to Suezmax. The worst thing, you can see the red line with the figure 13. It's the number of days of the shortest passage of a tanker taking oil from the region going to Rotterdam. To bring the same oil to China, you need to spend 123 days, which means 10 times longer. It's a roundabout voyage, just as in case of Rotterdam. So the transportation price grew, insurance price grew, and companies receive less benefit. LNG feels nice. In the summer, we start taking to Asia because the roundabout time twice as much. This is why R4 and no ice class vessels are called, and they transport to Europe mainly. And in summer they sailed, and they are sailing now towards the east. So seasonality, number of passengers per month of every day. Arc 6, Arc 7 only one, Arc 4 and Arc 5 later on. And then Baltic class and no ice class vessels are used in summer. And this blue line starts from 30 millions go to up to 40 millions up. So the basis for winter is 32 million tons per month as recalculated per annum. In summer, the capacity is 38 million tons. Seems to be nice. How different ice class vessels behave. Arc 4 and Arc 5 work all year round. One may think, looking on the previous slide. It's true and not true at the same time. The western part is served by Arc 4 and Arc 5, but in the eastern part, the situation is different. First and foremost, ice and no class vessels don't use this navigation vessel, because in the beginning and the end of navigation, ice conditions are far from being favorable. But Arc 4 and Arc 5 don't go beyond this beneficial time span. And when we talk about high ice class vessels from February to the beginning of June, we don't see them on the route. This picture, I want to reiterate, shows the trend of all hydrocarbons from the Arctic, including the Pichora Sea. I'm sorry, it was oriented to be exported to Europe. What happened on May 16? Head of the Ministry of Energy of Spain announced that very soon the EU would introduce the ban to transport LNG from Russia. The unofficial ban exists even now, whether the official ban was not imposed. And in December last year, Europe renounced to the tanker transportation of the Russian oil. What does it bring? It brings the fact that we need to change our logistics schemes. We can use the southern route or the northern route. No other options are available. You see the little column to the left. It's the current 2023, and it starts growing rapidly year on year, and we really need to bring this toward the east. One man show is our Vostok oil up until 130 million tons. It's the dark green part of the column. What's going to happen? Head of Rosatom, Mr. Lekhachev, said to Putin that we fly here to transport oil from the Baltic Sea. Yes, but we don't have vessels to use, or the window of opportunity is too short. Expect large transportation volume is not something that we can be sure about. The down left-hand side shows who and when can work on the Northern Sea route. Starting from November 16, no ice vessels cannot work. But in reality, only Arc 7 plus vessels can work. Arc 8, it's only a German or Swedish icebreaker. We have only 32 vessels of Arc 7 class. 32 only. Novatek's vessels, Sem Novopartovsky vessels, and 6 vessels of Nornickel. And Novatek is the only one to be really interested. And we discussed today with Novatek that we had an event of social partnership, and they really hope to have not old Marjorie or new ones constructed based on Samsung and Hyundai designs. When we talk about all year-round navigation, it's all about one player, Novatek. We don't have enough vessels to do all year-round navigation, and we don't have any reasons to do so. You can take a look at available infrastructure. We had a gift on the Pioneers' Day. The Ministry of Finance of the US included Geografическое предприятие state company that deals with all port designs and constructions along the northern route and the entire nuclear fleet all in all. And we have expected issues that would be solved on a day-to-day basis. And 2 very short topics. We talk about all year-round navigation. We talk about larger cargo traffic, but we also speak navigation safety, but we never know what's behind it. First is the vessels of the Morspasslujba, and they need to come to distressed vessels, like being in fire or being brought to wreck. But the thing is, if we look at the right-hand side graph, On average, in average ice conditions, none of the existing Morspatslужба vessels can work without icebreaker assistance. And even when Irish Icebreaker 7 would be constructed in Turkey, she will still not be able to operate. What about coordination centers? It's just about a guy with a cell phone. 16 vessels are being constructed, and we still have Icebreaker 6 and Icebreaker 7, which means that we need to apply more efforts on that. And second, in Violet, you have Mi-8 flight range 320 kilometers. We will have all in all 4 Mi-8 AMT CH-VA. They have the flight range of 465 kilometers, like 50% more versus conventional Mi-8. But why 2 first helicopters would be delivered to Murmansk? They had more issues to be solved in Murmansk with the Gulf Stream and not during the Northern Sea route. Well, the answer is evident. Wrapping up, when we talk about navigation development and forecast, we should say that nuclear fleet under sanctions would have its impact on cargo traffic and transnational operations. What will be the magnitude of the negative impact? We'll see. Second, we know very well that 21 gas carriers should be constructed for Arctic SPG-2. And I will give you more details later if you would. But instead of 21 vessels, only 5 would be constructed, 2 at Zvezda plant and 2 at Dev plant. And one may say that everything is bad. At Mitsu Airlines, it constructs in Korea, just wonderfully, 3 new gas carriers. And then, based on the long-lasting freight contract, and they own these vessels 50-50 with Chinese, and it's going to work just fine. Why this scheme shouldn't be used? Every friendly company could construct where it needs to construct and then give for long-lasting freight to us. Second, unfortunately, these vessels are not equipped with helicopter platforms. Yes, they can be used in the eastern part of the Northern Sea route, but they should provide to the aviation the possibility to receive helicopters on board. And talking about real suggestions, we had the Emercom exercises April 5 in Murmansk. It was a fascinating exercise, and we discussed with the Emercom that we can place Emercom effective on board of the icebreakers and to strategically place their helicopters. And I'm really wrapping up. The situation is tough. We are in the new reality. As Madam Nabiullina said in the end of March last year, this is serious and it is here to stay. We need to learn how to live in the new reality. We need to take our rose glasses off and to rewrite our ambitious plans, 80 million tons per year, because those plans were written 8 years ago. Now it's a time to understand what is feasible, what is not. Thank you for your attention.
Thank you very much. As always, nice in-depth analytics and great thoroughness. Moving on, I'd like to give the floor to Mr. Doronin. I'd like to hear a couple of words on the Arctic as a strategic area in Russia and how it needs to be developed strategically as well. Thank you, colleagues. Thank you for the invitation. I'd like to appreciate the way this conference has been put together because it's an important step for us. Our stint as chair of the Arctic Council didn't deliver all what we had hoped. Maybe we were excluded from some organizations, and such fora as this are very important. Geopolitical tensions involving Russia will be affecting academic international cooperation as well, and I think this forum is very important. Arctic is becoming mainstream today. I share the pessimistic outlook, more or less, but it's true to life. The challenges are huge. Still, it can be argued that for the past 5 years, there's been a revival in the Arctic of sorts. The state resuscitated this as a development area, and I have too many slides, so I'll try to go quickly through them. Let's skip my foray into history and focus on the social and humanitarian aspect of this. You know, the northern character. We heard about adaptation to climate change, and we heard about adaptation to the new economic reality for the Northern Sea route. I think Russians are the best in adaptation globally. Our climate shouldn't be habitable, ideally. Looking at the continental part of the Arctic, where there is no stable agriculture, there isn't anything to gain from the land except for minerals. Still, we have been able to overcome these adverse conditions. This high adaptive capacity translates into stubborn character and perseverance. On the other hand, this gives us this belief in a better future, which places us right in between Europe and Asia. The unique character is in great part influenced by our northern lands, I dare say. The Arctic dimension of the Russian states is something like this. We've been living there since the 13th century. This land wasn't conquered, but just populated, and the relations with the indigenous peoples were trust-based, unlike what you had in North America. Then our activities are evenly paced, conservative, we are open-minded, but still stubborn, which is a cocktail that makes me confident that we will survive into the future. The significance of the Arctic region boils down to talent, in my view, currently. There is a strategy for the development of the Arctic through to 2035. We've contributed to that as well. And one of the key goals there is that all the social parameters and indicators in the region are brought up on par with the rest of Russia. So the quality of life of 2.5 million people who live there should be as high as what you would have in central Russia. There is a regional element in this strategy, it's a first where a national strategy mentions each of the involved regions by name and gives detailed plans for development, including economic development. Then you have resources. Here is a picture from Stratfor, with some link to the CIA, where they show the disposition of resources in the Arctic, highlighted in black. And it covers a lot of the Russian Arctic and the Russian shelf. So it is something to work for. We are developing the Arctic to capture and ensure strategic reserves, not just for us, our children, but also the next generations after that. There are reserves that have been surveyed, and there are potential deposits that can serve as a foundation for sustainable development of many generations to come. And then you have the Northern Sea route. The transit potential of this route, as stated from high rostrums by the government, has the right to exist, because we have been looking for this route together with the Dutch and with the English. We were able to do that only 100 years ago, where the explorer Sibirikov did that within one navigation. So it's a relatively recent advancement. There are challenges and problems, that is true, but capacities have been building up. There is a plan to develop through to 2035. It will require some adjustment and course correction, but the cargo flow is going up. As soon as Vostok comes online, we are told that they'll add another 30 million to that. Of course, you need to develop infrastructure, including ports, emergency response infrastructure. But this is already all in the plans. There are strategies, documents, and roadmaps for that. As for the challenges, let me briefly touch on that. Here is another image. The alliances in the Arctic are 7 versus 1. Russia and the rest of the Arctic. The confrontation in polar latitudes will be intensifying, and the promise of the Northern Sea route is very important here. Russia is currently a monopoly in the polar latitudes. There are going to be disruptive activities against this, and it's a challenge. Then there is the climate challenge. It's been discussed extensively during the past session. Importantly, the infrastructure that we have and our adaptive capacity are being developed as well. There is monitoring for permafrost. There are corporate systems with different instrumentation as well. In permafrost areas, the pylons that are used to lift the foundation are pre-frozen, for example. It's a technique, a building technique, and it's also something to ensure adaptation. Then there is the population challenge, because there was an outflow of people a couple of decades back, but then we needed a huge injection of people to support economic activities. In the risk, for example, the Azerbaijani community is many thousands strong, and of course we are welcoming and respectful. The utilities are being worn down, but it's being worked on as well. To sum up, our motto is responsible governance for sustainable development in the Arctic, and there are concrete examples of that. Security, for example, there is a single chain of command for the Northern Fleet. The regional response forces of EMERCOM are also there. Then you have development of the Northern Sea route. Here is the ice-class platform. I always cite this as an example. unique research vessel, which is going to be a stepping stone for us because it will enable fundamental knowledge for business. Renovation of cities is going on in the Norilsk, Murmansk, and Arkhangelsk. It could be faster, yes, but it is still something that exists. The same applies to villages. And then there are mineral extraction projects. Vostok Oil, where you have oil. Despite all the restrictions, LNG is going to be in demand. Conventional metals mining is also there as well. And new metals are being developed as well. We'll start mining lithium there pretty soon, a first for Russia. A new generation of metals mining to support the energy transition. Thank you. I tried to, give you somewhat of a positive outlook. Thank you. I understand that you have a lot to share, but there are other panelists as well, and we are limited on time. Mr. Grumov, a nice segue into this ICE class platform. What are the key outcomes? Just recently, the personnel shifts rotated there, and the platform continues to drift out in the sea. So what's the situation there? Let me congratulate you on this great holiday, the Day of the Polar Explorer. Wish you strong health and new achievements in the Arctic. This year, the celebrations are shared by our colleagues and friends who are currently out there in the Arctic Ocean as part of the drifting exhibition North Pole 41. After a gap, we reinstated the program of free floating stations drifting the sea. It started out in 1937, then there was a gap, and now we continue. It's not, the novelty here is that it's not a lump of ice, not a platform, but an actual vessel. For the first time, it's a special purpose ship. North Pole, or ice class, self-propelled platform was built last year, commissioned last year in St. Petersburg. Its autonomy indicators are impressive, 1 year in terms of food and more than that in terms of fuel. Its body is as strong as Arc 8 class. It was a fast-paced story. Last year it was handed over to the Arctic Institute, and then in October it set out to sea for the first time. You are aware of how this works, so you can imagine what a challenge this was. But we managed, and on September 27th, the vessel arrived to its destination point to the north of the Isles of Novosibirsk. Over the 5 years, it identified an ice cake that was suitable, attached itself to it, and started drifting. The first message from the meteorological station was soon to follow. There are all the conventional research areas that we have: geophysics, meteorological, but then we also have our partner institutions in biology and geology. The vessel has 17 fully furnished labs to ensure operations both on the vessel and in the camp set up 500 meters away from the vessel. Over 8 months, the vessel traveled 1,250 nautical miles, and its general drift was 500 30 miles. It goes along with the flow. The plan provided for 3 visits. One such visit took place in April. And 74, a plane took off in Hatanga, had an interim landing on the Northern Land archipelago, and then proceeded to ice base Borneo, set up by our partners. From there, from the Borneo base, people and cargoes were taken to the platform by helicopters. The logistics of this are incredible, and this would have been impossible without new runways on Baranov Cape, commissioned this year. This airfield was years in the making, and a whole expedition went there to prepare the ground. I'm sure that this will be a great addition to our logistics in the Central Arctic region. There's going to be another rotation this year. The expedition shift will change. This time we'll use Academic Tershnikov, our research vessel, that will set off from Murmansk in August, go to the platform, and deliver the handover shift and cargoes. This map is indicative. We'll see how it goes actually, and plot the route based on the ice conditions that are present at the time. I hope that our ice forecast experts will help us to optimize the route. For the first 8 months, almost 8 months of drifting by the expedition, we have collected enough information to draw preliminary conclusions. First and foremost, the vessel has proven effective and suitable as a platform to support research in the Arctic. The safety of research was greatly improved by the introduction of the platform. And this vessel is like a fort, because conventional camps can be subjected to adverse weather and ice conditions. This vessel served as transport and a home for the researchers, which is again a fortress. It is also a lab, a research lab. Going forward, we believe that it can become a platform for interagency and then international expeditions to the Central Arctic. We are designing an approach to expeditions as we go along, and we hope that it will prove useful in the coming years. This will include the vessel itself, our support vessels, research vessels Tereshnikov and Fedorov, and that airfield that I mentioned, just installed this year on the Cape of Baranov. Overall, this platform vessel puts us on the map in the Arctic for the coming 30 years in terms of research. It's a priority for us, and the Institute is going to continue doing that with all possible efforts. Thank you. Thank you very much for your report. I just wanted to add that there are 5 options and alternatives of where it will go this year, given that it's drifting in sea. It's a challenging project in terms of organization and supply, and we are learning a lot as we're doing this. Thank you once again. Then I wanted to give the floor to Mr. Chernov. Our institute has a unique research center. We have an ice pool. It was built in 1955, a first of its kind in the world. So let's hear briefly on the ongoing projects there and how we are advancing ice simulations.
Good afternoon, esteemed colleagues. The ambitious goals that were mentioned today cannot be achieved without unique engineering facilities and unique machines dedicated specifically to function in the Arctic amid extreme conditions. Nuclear icebreakers and high-capacity gas carriers and LSP, our difficult child. Often I hear saying about unprecedented in the world, but our items really have no precedence globally. In order to create such items, we have our laboratory, the complex of ice pools of the AARI. The existing complex was opened back in 1990s. Last year, we received a subvention from the Ministry of Education to modernize the pool complex. And we implemented this grant. So what do we have available now? Our big ice pool is roughly 30-meter long, 5-meter wide, and 1.8-meter depth. Up to 60 millimeters, we can model the ice. It allows us to create models like test body shape, load of different icebreakers, vessels, fixed engineering buildings. We have several bay that participates. New icebreakers are tested here. We need to organize container traffic all year round along the Northern Sea route. We worked in this project as well. So quite big amount of tasks are being solved here in the pool. It requires necessary capacities from us. Within the modernization, we commissioned 5-axis working machine. It's a milling machine that would allow us to create models up to 4 meters long during one single technological cycle. We shift from conventional technologies when we received a drawing, a blueprint as a reference document, and we switch towards 3D modeling. Theoretical drawing can be created in the end of the project. We start the project from 3D models. So we insert ourselves into the modern technological ship design cycle. Moreover, as a part of modernization, we procured this complex is not manufactured in series. It's a propulsion model, so we can simulate almost any propulsion scheme. 3 azipods, 2 azipods with the screw propeller. Any architecture is feasible. It improves vessel maneuverability, exit from the channel, movement with intermediate modes. It's a unique feature. It has not been commissioned yet. And every day we test this piece of equipment. It's like a toy. We received it, and I'm fascinated. Talking more seriously, we can proceed to more different exercises now and experiments. Our test results should be verified in real nature. And the full level test is a mandatory step to commission a vessel to its owner. And we tested many vessels, and we have research vessels and tankers, gas carriers, icebreakers, delivery vessels. In a couple of days, our colleagues depart to test nuclear icebreakers. This fall, we will test an icebreaker for the marine. Last year, and it was a unique operation for us. We have never done this before. We tested full level. We proceeded to full level ice test of the Everspare. The very first time we tested the Ballard pool. We developed the methods, we developed the technology, and I hope that we were successful in our tests. Moreover, why I'm talking about the pool complex? Because we have the little ice pool. It is here to study ice physics and ice mechanics. Its size is 5 meters by 5 meters, and we can have the ice up to 1 meter deep. So we took this sample from the ice, and the thickness is roughly 1 meter. We can vary ice salinity. We can go as low as minus 30 degrees temperature. This is the range that can be practically used, and we hope to have this cooperation within and without the Institute. It's a good testing facility for subvention tests. When we launched the little pool, it allowed us to proceed to this interesting work. It's a new thing for us. Maybe the picture doesn't speak for itself, but we studied the interaction between new materials and ice. We worked with the R&D Prometei Institute, the flagship of the material science for vessels and from nuclear industry. And we tested the attrition or abrasion of steel parts against the ice. More than 1,000 kilometers were covered by steel pieces with different loads applied. So we open a new niche for us, and I hope that it's gonna bring us further new cooperation opportunities. This dimension is really something that we are looking forward to. We invite everyone to cooperate with us. Just a couple of words about the challenges that our laboratory faces. I would like to start by saying that we feel that we are in the right flow, in the right steam. There are a lot of technical and engineering questions that are yet to be solved. Therefore, we receive different inquiries, different demands, a lot, really. One of the main challenges is our readiness to try something new, to innovate. We talk to a potential client with questions that we have never answered before, and we should be ready for that. Second, it's also a challenge to us. A certain degree of competition, not only vis-a-vis our competitors from other countries, but also from the side of quantitative methods. I heard a lot about a digital pool. It's not something that will appear tomorrow, but we should be ready. And at this verge between real-life modeling and real tests results with digital methods, it will propel us to a long-lasting strategic way of working. We invite to cooperate with us. Happy Polar Expert Day. Thank you, colleagues, indeed. 3 days ago, we celebrated the Polar Expert Day, and I invite everyone to join me at the standing reception and wrapping up our day, wrapping up our conference. I would like to say that despite all risks, challenges, and complications in the Arctic, I'm sure that the Arctic will live and we will live. Happy holiday.
Приглашаю всех.
I invite everyone to the mirror room just outside our big hall.